Okay, it's unfortunate that school schedules are the way they are. It would have been nice to keep you for an extra period on Friday and finish the discussion. But hopefully if you looked at the homework, what I'm going to say today really clicks right in with it. Yeah, I think it's a part 2 of that lesson. It says using trigonometry, solving for sides and angles. What it means is take what we saw on Friday and actually do something with it. There are many people that would argue this is the most important lesson of grade 10. Well, that makes it sound like it's going to be difficult. I don't think it's going to be difficult at all. But you use this trigonometry in grade 11 math, in grade 12 math, in calculus, in physics. You use it everywhere, okay? But it's set up pretty nicely, I hope. I think we set it up pretty nicely to finish the job here. Here we go. Determine the values of sine, cosine, and tangent ratios for specific acute angles in right-angled triangles. And solve all right-angled triangles, stuff we couldn't do before today. Your skills were limited, actually. You needed 2 angles, or you needed 2 sides. Today, we will not need that much. But for those of you who did your homework, this will be easy. For those of you who didn't, geez! I say, recall the primary trigonometric ratios. I encourage you to circle the angle you're using because that can actually confuse you. I'm going to use A. And if I use A, that means the side over here is opposite and this one's adjacent. Those will change roles if I had chose a different angle. Hypotenuse is always the hypotenuse. Oh man, it's like hypotenuse. So does anyone know, without looking, did you accidentally memorize or on purpose memorize which one sine A is, which ratio it is? Is it opposite over hypotenuse? You really want to get yourself to that point. If the homework doesn't do it for you, if you don't use it enough that this memorization comes, then you go back to so katoa, that word, and like I say, even in Walmart, you can walk down and say so katoa out loud, and 3 people will go, point at you and go, I know what you're talking about. Yeah, because most everyone remembers so katoa, even if they don't use it every day. How about cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. The better you have these memorized, the faster the questions go as well. That's not always true in math, but it is true here. The better you know these, the faster things go when you go to do trig. And then tan, good for you, opposite over adjacent. That one maybe comes easier because that's the one we used for the investigation. It's the dangerous one. You need to make sure that you use like an SPF 50 when you're doing that one. All right. Someone says, why are they this way? Couldn't you go the other way? Couldn't you go hypotenuse over opposite? And the answer is yes in grade 11. We'll talk about that. But for grade 10, this is all we need. This will work. We can do it this way for now. Note, the location of the opposite and adjacent depends on the acute reference angle used. I go back to my example. For you, what side of the room is the clock on?
I don't know, the right?
Right. That's right. It's right. But for me, it's on the left, and that doesn't surprise you. You're not caught off guard by that. And that's exactly what happens with opposite and adjacent. If I used this angle up here instead, opposite and adjacent switch roles. So you got to circle and label carefully. The rest will be pretty straightforward. Very repetitive. Very repetitive. I didn't say easy. Very repetitive. Example 1. Find the sine, cosine, and tangent of an acute angle. Evaluate using your calculator. As it turns out, your calculator knows all the triangles. As soon as you hit sine on there, it immediately starts drawing opposites over hypotenuse in its brain. It goes, I'm ready for you. That is not how it does it at all. But it's fun to think of it that way, that the calculator's busy doing calculators. So if you go to your calculator, and you got to be careful to be in degree mode, it's called. Let me find my calculator. And we'll talk about getting into degree mode, because that can actually cause you some heartache. So get out your calculator. And if you've been a borrowing calculator person or you've been a phone calculator person, it's time to commit. Yes? No more of that. Commit to one calculator. Say it, you and only you. So you know where the buttons are. Yes? And then once you have your calculator, get to know it. Yes? If you haven't got to know your calculator, maybe this week, dinner and a movie, spend some time getting to know them. Find out what makes them go. For us, make sure you're in degree mode. Mine comes up in degree mode. Maybe it'll say D up there. Check right now. Does it say D? You don't want to be in the other ones. Rad. It's rad, dude. That sounds awesome. It is awesome, but not for us. Yes? Grad. I want to graduate. Not allowed to press that button until you graduate. No. That's actually called gradients and used by engineers. Okay? We're still degree people. Yes, we'll stay degree people. So, if you want to know sine of 30, your calculator's no problem. You don't, or tan of 25, sorry. It says find tan of 25. You don't need to draw, like we did on Friday, 5 triangles, average all the answers, and hope it was accurate enough. Your calculator goes, I got it. I'll draw the triangles for you. Tan, 25. And then the question is, how many decimal places? Now, decimal places are a bit of a problem. What we say is most answers we want accurate to like 1 or 2 decimal places. So if we take 4 now, our answer will stay accurate to 2 or 1. If you take only 1 now, your answer might not stay accurate to 1. As soon as you round off, yeah? So 4 is like a safety procedure that we use when we're using sine, cos, and tan. We go, I want to make sure this thing's accurate to 1 decimal place. So to be sure that's going to happen, I'll take 4 right now. So I get 0.4663. Mr. Todd, how are we going to use that? Just relax. I'm not done yet. For now, let's just make sure we can get our calculator to do this when the time comes. Huh? What? What happened? All right.
I think it's a syntax error. I pressed it on and it undid it, but I don't know what that is. I'm curious.
Tan, 25.
Yeah.
Is good?
Yeah, that's good.
What's happening?
I don't know. Wait, if you do sin and hypotenuse, it gives you an answer. It does that. What's that mean?
That's sine hyperbolic.
What's that do?
Second year university.
Oh, that sounds fun.
Yeah, it is fun. Hyperbolic. Yeah? Scary. Scary. Don't worry about that. Don't get distracted. And don't distract me. Kids these days. How about sine? It's pronounced sine, Catholic friends. Don't even say it. It's not the 7 deadly signs. Sine 30. Actually, 1/2. That's interesting. That will be very interesting next year. This one comes out to a nice fraction. It's set to 4 decimal places, so I'll just write 0.5 to do the decimal type thing. Do you know the 7 deadly signs? Let me try to remember. No, hang on. I can remember. There's dopey, sneezy, doc. Those are the 7 deadly dwarfs. Whoops. I got that wrong. Wrong book. Wrong book. Cos 75. It's cosine. Everybody says cos. But cosine 75. Does yours do this? Root 6 minus root 2 over 4? Clearly there's more to the story here. Yeah? Just hit change and go. Just give me the decimals. Don't upset me on a Monday. 0.2588? Yes. Yeah, no joke, yes. That's the, if we have to keep it exact because we're doing some intense calculation, there must be more to the story here, and we'll get to the more of the story.
Is sin 1.5 times 10 to the power of -4? No. Because I just pushed sin and then I pushed answer. So does that mean?
We're doing sin.
Just you press sin and then just push equals.
No, just do what we're doing. Yeah. And that's all for now. Okay? Now, folks, not all calculators work the same way. Hopefully yours, you go tan 25. There are some calculators out there where you have to go 25 tan. I don't see many of them around anymore, but I prepare you for that just in case you grab someone else's calculator to do some work. You might have to go 25, then hit tan. And your phone probably works that way too. These are good calculators to take to the first, no, not the first date, to your first fire party this year. Roast some marshmallows, and then roast that calculator right afterwards. Then we got to let them go. They're horrible. Yeah? If your calculator puts it in brackets, some calculators are actually picky once they open a bracket, which is good. That's a good feature on a calculator that opens the brackets for you. Some calculators actually make you close the bracket. Some don't. So, okay, be aware of those two things. Those are minor details solved by just getting to know your calculator and using your same calculator for all your homework all the time. Now, your calculator will do the reverse for you. It also finds acute angles. Again, we must be in degree mode. To solve for an angle in a trig ratio, use what's called the inverse. And by inverse, I mean, yes, inverse. Hang on. By this, what I mean is, let's go back to x squared equals 71. When you run into that, the first time you get taught that, hopefully you were taught to go 7 squared is 71? No, it's not. 8 squared is 71? No, it's not. 9 squared is 71? It's too big. And you're like, what are we going to do? We just play around and trial and error it? No. There's an inverse function to squaring. We know that we can inverse squaring. We can undo it using square root. Thank goodness. How hard would unsquaring be without square root? It's ridiculous. You'd be sitting there all day. So you can do that way. Sine has the same thing. Cosine has the same thing on your calculator. They all have an inverse. It's an unfortunate symbol, but it looks like this. If you want to find what angle gives this as an answer. See, there's the 4-digit answer. What was the angle? You just hit what's called tan inverse of 0.3711. All you have to do is hit second function or shift tan and go, no, I don't want to do tan. I want to undo tan. Just like square root undoes squaring. So I go second function tan, and it comes up with a little tan -1. The -1 is unfortunate that they use that as the inverse, but it means undo tan is what it should really say. That would be great if that button said undo tan. And then undo tan on 0.3711. Tell me what angle this person used to come up with 0.3711. And it's 20.35 degrees. I'm going to go nearest single decimal place because I need to tell you, degrees are really small. 1 degree is a tiny little angle. So 1 decimal place is plenty here, okay? Well, if you got that, you don't need my help for the other ones, but I'll go through it and re-explain it again just in case you fell asleep there. Yeah. Drifted off. This one says someone did sine of some angle and they got answer 0.3907. My question is, what did they do sine of? What was the angle? And the calculator has a button for that. I got to do shift sine or inverse sine. So I got to do sine inverse of 0.3907. It's x squared is to root x as sine is to sine inverse. It just undoes the operation for you. So I hit sine inverse 0.3907, and I get 22.998. Oh, that's nice. Obviously, they did 23 degrees. Yes? That is rounded to 1 decimal place, actually, friends, if it's 22.99. Did you get 23 degrees? Totally fine. Yes? But you want tan inverse. We've been doing tan inverse. So you want to do shift tan and then enter the 0.3711. The bracket's good, actually. You're going to like that's got a bracket. If it forces you to do a closed bracket, fine. Some calculators don't. You don't have to close the bracket, but maybe you should. Yeah, I don't know. Well, this looks bad, but if you get it as a fraction, it's no problem. You just enter fraction in there. Shh. Just enter fraction in there when you cos inverse. So cos inverse, open bracket, 9.1 over 17.4. I love how this looks. I hope your calculator you can make look like this too, where it says cos inverse, and all of that stuff is in one nice bracket with a fraction there. Those are the calculators you're going to like. Not because they're fancy and they're cooler than everybody else's. No, you're just going to like it when you're doing your homework. You'll be able to see exactly what's happening and hang on to your calculator like this now. Maybe it's time to upgrade too. Bring your calculator to me if you're like, and we'll talk about what a really cool calculator is. Yes? Equals. Do you get 58.46? But I'm going to start getting used to nearest decimal place in degrees. Like think about even moving my hand 1 degree. It's like, I don't know if I can even keep to, like a degree is already really small. So 1 decimal place degree is fine. Okay, you tell me your questions. Again, if you've got a piece of junk calculator, you might have to press it the opposite way. You might hit the number and then hit second function 10. If you're using someone's old calculator at home, or if you're using your phone, you might have to do it the other way around. Stop doing that. Start going, travel with your calculator. Yes? St. John's uniform, 1. Calculator, 2. Those are the 2 things you need. Your lunch is 3 now. Yeah? It's important that you have your calculator all the time. Shh. I'm on slide 3 of 6. I'm on a roll. No more random comments. Need a projectile to use for the next random comment. Okay. Get ready. Now we're going to do some stuff. That was all theory. All of Friday and all of Monday so far, all theory. Now let's do something. And the first time through it might seem a little confusing, and that's why we're going to do 3 in a row. When you see 3 questions in a row like this in math, you're like, okay, the first one, I don't have to understand it perfectly. I got to get what he's saying, kind of. On the second one, I'm like, I better get close now. I better start to understand what's happening. And then by the third one, you're like, okay, I got it. Get ready. Step 1. Circle the angle you're going to do. It says determine theta. It's called theta. You want to be cool, call it theta. Don't change its name to A because you're not used to saying theta. Get used to the Greek letters. They're really cool. Circle the theta. Then label the sides. This is Friday's homework. If that's theta, what's the 13 called? Hypotenuse. I'm going to use HYP. I'm going to find a halfway point in the short forms. Calling them H can be confusing. Don't be quite that lazy. I think you want to go with hype. Yeah? If theta is the angle I'm using, what's the 5 called? Opposite. Meaning the remaining one's the adjacent. But I don't have that information. You can label it adjacent if you want, but I'm trying to get you another step along this process to be like, I don't know what adjacent is. I know I could find it using Pythagorean theorem. But I'm telling you, you don't need to. I can get this angle without doing that by writing this down. If I'm using opposite and hypotenuse, which of the 3 trig ratios would I be using? Sine, how did you do that so fast? Opposite hypotenuse. So you see, that's why memorizing it gives you speed, knowing that sine is the one that does opposite or hypotenuse. So then you'd write sine of theta equals, what's the opposite? 5 over 13. That's where you were supposed to be when you came in today, so that I can write that down. Here's what I've added. What angle do you press sine and get 5 over 13? I don't know. If only there was a button on your calculator that undid sine for you and found out what the ratio is. There is. What's it called? Sin inverse? It's the sinverse. It's technically called sine inverse in this building. So you'd go, oh, I want the angle. I don't want the ratio. So I do theta equals sine inverse of 513, and I just hammer that into my calculator. We're having all sorts of problem with the board today. I'm going back and forth with my computer for a while, trying to get everything to work right here. Let's see how I do. Sin inverse. What was it? 5 over 13. And again, if you want your Math Cool badge for your Boy Scout outfit, you'll type it in the way I do it, like that. And your calculator will look like that. And I get 22.6 degrees. And notice the question this time does say to 1 decimal place, because for degrees, 1 decimal place is plenty. I don't know if that's easy or not, but I do know it's very repetitive. Once you can do one of these, they're all the same. So I'll do the second one with you a little more slowly, get some help from people, and then you'll try the third one on your own and see if you got this. What's the first step in these situations? You're both right. Maybe you're past circling, but I encourage you for a while to do it my way and circle the angle you're going to use. Then label the sides. What's the 11? Hypotenuse. What's the 5? Adjacent. You can label the third side opposite if you want, but since I don't have it, I'm not sure that that actually is helping the situation all that much. I've got adjacent and hypotenuse. Which ratio am I talking about if I'm doing adjacent hypotenuse? Cosine. And memorizing those makes you fast. So I know that the cosine of this angle is adjacent over hypotenuse, 5 over 11. So someone hit cosine of an angle and they got 5 over 11. We want to know what the angle is. What are we going to use? How did you do that? Cosine inverse. He's saying it right. I encourage you to call it cosine inverse. I know it's a -1, but the -1's going to mess with your brain and make you think something weird's going on. It's just the symbol. And what did you get? 62 point. I just didn't hear you. 9? It rounds to 63. Oh, let me check. Because I don't want you to scare you with the rounding, because we're not that worried about the rounding, but we better at least talk about what the rounding really is as long as we're doing it. 62.96. Really, it rounds all the way up to 63. And that's weird, and you future physics and chemistry people, in this situation, what you'll write probably is 63.0 to let people know, no, I looked at it. It's not 63, it's 63.0. It's actually that accurate. A lot of chem, a lot of scientific notation yet in chem? Anyone taking 11 physics yet? I hope you haven't. You'll do better once you have some more math. Yeah? Okay, you try this one. I'll do it slowly. Well, let's. They're extremely repetitive. Yeah. I've done the circling and the labeling. I've done Friday's work for you just in case you didn't do any homework. You're fired. I love it. A non-distracting question? That's what you're going to ask me? Hold on. Let me check where we are here, and then I'll take your question. Okay. Was that enough time? Were you okay? It should be. If you get what's going on, these should go pretty quick. Did you get 56.5? You were happy? Austin has a question.
So is it possible for the opposite to be smaller than the adjacent?
Yeah. The opposite adjacent can be, one can be bigger than the other, so that's why you get a bigger side on the top this time. The hypotenuse has to be the biggest one. Something's wrong if you haven't found the hypotenuse to be the biggest one. But opposite and adjacent, one can be bigger than the other. Yeah. You have questions? What about sides? That should be your question. You've done angles. What about sides? Can do sides too. Right. When you came in today, like, we can do sides. Just give me two, I'll find the third one. The first question comes up and says, you only gave one side. You couldn't do, you would have said, a week ago, if I had put that triangle up there, you would have said, I cannot find the other sides. Now I say you can. Watch. Watch. Again, 3 examples the same in a row. Yeah, pretty much. So if the first one you're like, I don't know, that's okay. Yeah. First step in these questions. I can't do that till I decide what angle I'm going to use.
Oh, label the angle. Even though the one we have.
We have one angle, circle it. If they give you both angles, circle one of them. It doesn't matter. Circle one of them to choose and use that to label the sides. What side is the 18? Hypotenuse. What side do I want to get in the question? The opposite. So that's how these questions are a little different, is you're going to label the side you want, because you want that involved in the question. Then you just write down what you got. Oh, opposite and hypotenuse. Which one's that? Sine. And if you're not that fast yet, that's okay. But I encourage you to get that fast, not because you need to know it for the test, because you might need to know that. What I mean is the homework's going to go like 10 times faster if you first take 10 minutes and memorize the Sakatoa stuff so it happens quickly. Yeah? You don't want to sit there every question going, opposite hypotenuse, which one is it again? I don't know. Yeah? You want to get, bango, you got it. So sine, this time we have the angle, equals opposite of hypotenuse. I'm going to write it this way this time. Then you get a scared, because you go opposite is x. I just put x in there. I don't know what x is. I'm like, I know, that's what the question's saying. Don't panic when x is in the question. X is the unknown. Yes? As long as you know everything else, you're okay. And the hypotenuse is 18. Now you is sad. What am I supposed to do? There are 2 choices. What do you like? Cross multiplication. Wait, it's not a fraction. Make it a fraction. What fraction can you always put over? Put this over 1 and cross multiply. Oh, that's why we did that first. Yeah, we had a plan. These are similar triangles. What do you mean they're similar triangles? My triangle has an 18 in it. The calculator has found out for me for all 37-degree triangles. Don't worry, for all 37-degree triangles, opposite over hypotenuse should be some number. Well, when I cross multiply, I get x equals 18 sine 37. And are we going to now all draw 37-degree triangles, measure the opposite and the hypotenuse, average all our results to find out what sine 37 is? No, of course we're not going to do that anymore. The calculator has all that information, so you can just, in your calculator, type in 18 sine 37. I get 10.8. And friends, now we're cooking with gas. Any right angle triangle, you give me 2 sides, no problem. I can finish it off. Give me 2 angles. I can't finish it off. Give me 1 side and 1 angle. I'm off to the races. Because now I can Pythagorean theorem the third side. I get some of the angles the other side. I can finish it all out after that point. Once I get 1 more piece of info, all your grade 9 weapons come back online. Okay, that was the first time through. The second time through, you're supposed to be like, I'm getting this. The first step in these questions is what? Circle the angle you're going to use. Because now you can use that to label all the sides. Yes? You can label them all. If you're labeling them all, I love you. That is great. But you only need to label the ones you really need in the question, which I need to know opposite and I already know adjacent. If you label hypotenuse, it's beautiful. Me love it. But I'm trying to stay in my lane and saying, I only really need to label the sides that I either want to know or that I have. Okay? Whatever you like. So then, who wants to write the fancy mathematical equation that I have now? If it's opposite and adjacent.
Opposite over, wait,
10.
37,
10, no.
51.
10, 51
Last question.
equals.
Opposite over adjacent. So that's x over 30.
Yeah. Is good. Now your algebraic skills take over. We want to cross multiply, but it's not a fraction. How do we make it a fraction? Put over 1. And then we cross multiply. X times 1 is x. And over here I get 30, 10, 51. 30, 10. I'm tanning with my SPF 51 on here. 37.0. Yes, write the point O to say, yes, I looked at it and it made sense that it wasn't 37.1, it was 37.0. Mr. Todd, can they get any harder than that? This much. This much harder. If you've listened to all the instructions, this one might not phase you, actually. It might not cause a problem. But something small, tiny, goes wrong here. Hopefully, some of these steps are sinking in, though. First step, be quiet. Second step, circle the angle that you're going to use. If they give you 2, just choose one. Yeah, it doesn't matter. Just choose one of the angles to actually use to do the problem. Use that to switch pages.
Can we use the angle 90?
No, the 90 won't work because the 90 then makes it what's the opposite, what's adjacent, what's the hypotenuse. All this stuff, it's a great question. All the stuff we're doing only works for 90-degree triangles. A good sidetrack question would have been, what if it's not right angled? Don't worry, I got you covered, but it's going to be later in the week before we get there. But for right angled ones, don't use the 90. Choose one to do. So I take the 42 and use that to what am I going to do now I got the angle? Label the sides, yes. Opposite hypotenuse. And again, if you label adjacent, that's not wrong. I'm just saying that doesn't really change what has to happen here. If opposite and hypotenuse are involved, what's opposite hypotenuse? Sine. Thank you for not sinning anymore. Sine 42 equals opposite over hypotenuse. What just happened? Why is this big trouble? It's not big trouble. Why does this seem like it's big trouble? Because the x is in the bottom. Is that a problem? No, not at all. No, it's not a problem. Put this over 1 and cross multiply. X sine 42 equals 4.5 times 1. Are you okay if I don't write times 1?
That's fine.
Yeah, that's fine. Oh, but this has one more step. If I want x, I got to go one more step here. X isn't by itself. So I got to go x equals 4.5 divided by sine 42. So if Austin had to ask a on-task question there, he would have said, what happens if the x in the denominator? You're going to have one more step. Yeah, after you cross multiply, you're going to have to keep going one more time. So x equals 4.5 divided by sine 42 equals, do you get 6.7, friends? Yeah. Oh, man. That's the best lesson of the year, by far. Whether you're loving math in grade 10 or not loving math, you've got to love this because it's very repetitive. And repetitive stuff needs to be practiced. Yeah, that's when you get good at it. It's like shooting free throws, right? Get on the line and shoot. You know, watch LeBron shoots some free throws and goes, wow, he's good at that. Now that I've watched that, I'm going to be good at that. No, you are not. You still stink. You just watched me. I'm not claiming to be the LeBron James of mathematics. That's not what I'm saying. You just watched me shoot a bunch of free throws. You're like, wow. Now you're going to go home and watch YouTube. No. And go home, and I will practice. Yes? Just in case this chapter gets a little harder as we go. What's left? Nothing. Oh, I put the homework thing on a separate page because there's one little thing I got to talk about. Whoa! Page 398, page 403. Should go pretty fast, friends, if you know what you're doing. But look, it says, if asked to solve the triangle, that means find everything. Could I find everything now? Here, let's go back to here. Now that I had 6.7 as x, you label it on here. Could you easily get the last angle here? 180 minus 90 minus the 42, yes? Could you easily get the third side there? What would you use? The thing with the squares and the adding and the subtracting. It's got a name. You'd use the Pythagorean theorem. So yes, some questions have a couple more steps you're supposed to know from before. So don't go to the back of the book and go, Miss Todd, question 7 has 3 different things there. Like, yeah, it's got the other, you get one side, then you do Pythagoras, then you do some of the angles, and you finish out the other 2. That shouldn't take long. That should, an extra couple of seconds on each one. No, it's exaggeration. It's not just a couple of seconds, but Josh.
Who was the LeBron James of math? No. Your first Stephen Hawking.
Albert Einstein, maybe.
Charles Darwin.
That's not actually, that's not that.
I'll go with Richard Feynman.
Okay.
Einstein was the most brilliant mathematician of all time that got a chance with his life to do math. Yeah, there's plenty of people that, never got a chance to do math, but he was probably the most brilliant. Newton was probably the most hardworking. He did the most. He did the most for math and science. But Richard Feynman, the insights he had changed the course of the 20th century and really helped out. He helped out more profs, people, students find their way. Feynman, F-E-Y-N-M-A-N, Richard Feynman. There'll be a thing called the Lectures of Richard Feynman. He got to, and there's some good videos where he got to the heart of some really ugly stuff. He said, what if we draw it like this? And everybody went, right, now we can do it, yeah?